Now, today's topic is the biodegradable polymers. Yesterday, we discussed about the individual polymers like polyvinyl chloride and Teflon. After that, we see the condensation polymers, bakelite, and next we see the nylon 6,6, including their preparation, properties, and applications. After that, the next important polymers are the biodegradable polymers. I think this is the last topic for the CIE1 syllabus. CIE1 syllabus. So already we discussed at the introduction of the classes. Our syllabus is totally 5 modules. Out of 5 modules, the 50% of the syllabus, 2.5 units. That means module 1, electrochemistry and corrosion, and module 2, water technology, and module 3, engineering materials. In engineering materials, at the polymers up to biodegradable polymers, we have the CIE1 syllabus. I think all of you know the examination pattern of CIE1 syllabus, because yesterday in our telegram, college telegram, they posted our mid-examination pattern, and the weightage of the mid-examination is 20 marks, and there are totally 5 questions, and each question is divided into 2 parts, part A and part B. Part A weightage is 2 marks and part B weightage is 3 marks. Totally weightage of each question is 5 marks. And there is a choice also. Out of 5 questions, you need to write only 4 questions. 4 into 5, 20 marks. Okay. Okay, now let us start today's topic is biodegradable polymers. First of all, we see what are the topics covered in today's section. First, we cover the definition of a biodegradable polymers. Next, we see what is the introduction to the biodegradable polymers. After that, we see what are the classification, nothing but types of the biodegradable polymers, including both naturally occurring biodegradable polymers and synthetic biodegradable polymers. Next, we see individually the preparation, properties, and applications of each and every polymers. So first of all, we see the definition. So definition is biodegradability. So biodegradable polymers is coming out from a biodegradability process. First, you learn about the biodegradability. So this biodegradability is defined as the ability of being chemical transformation by enzymatic action of bacteria.
This is not changed.
Now it is visible, Amma. All of you visible definition slide.
Yes, sir.
Okay. So this is the definition for a biodegradable polymers. So biodegradability. So biodegradable means the polymer which is degraded by the biological activity. The polymer which is degraded by the biological activity, especially enzymatic action of bacteria. So biodegradability is defined as the ability of being chemical transformation, the ability of being chemical transformation by enzymatic action, of bacteria which are capable of further degradation, Okay, so this is the definition for a biodegradability, and comes under category of the polymers. Why? Because we learn about the biodegradable polymers. So these polymers are popular materials as they are not attacked by the environmental conditions, including biological attack. So generally, because of without reacting with the environmental conditions, they causes so much of the pollution because of especially like polythene bags. So some extent of the polymers are degraded slowly by the oxidation and UV radiation, etc., but not by bacteria, and this property creates the difficulty in disposing of the polymer waste. So because of without biodegradable nature of the polymers, the disposal of that polymers make a big problem, and it causes the land pollution. So for that purpose, to avoid the land pollution, it is need to create the biodegradable polymers. That means the polymers which are degraded by the biological activity, nothing but enzymatic action of bacteria. So now we see the introduction to these biodegradable polymers. So biodegradation of the polymers not only aimed at the eliminating landfills, but also compositable bags for the collection of lead and add waste. So already at the introduction of the polymers, we discussed about the classification of the biodegradable polymers in their occurring source, that is natural occurring biodegradable polymers, semi-synthetic and synthetic biodegradable polymers. So the naturally occurring biodegradable polymers, natural occurring polymers means the polymers which are obtained from a plants and animals like proteins and the parts of a plants, nothing but a leaf and add waste. So all of this causes a land fills. So those polymers which are degraded by the enzymatic action of naturally occurring microorganisms and bacteria are called a biodegradable polymers. Okay, so biodegradable polymers were used in the initially the Romans, where they used catgut for switches and which are slowly degraded by as wound heats. So this is the first biodegradable polymers used by the Romans, especially for the catgut for the switches, which are slowly degraded by the as wound heats. Okay, so this is the first example for a biodegradable polymers. And now see what are the requirements for a biodegradable polymer. So first of all, the production of a non-toxic products. That means they are not harmful to the human beings and capable of maintaining the good mechanical integrity until degradation. So up to degradation step, they maintain the mechanically strong. After that, we see controlled rates of the degradation. That means the degradation should not undergo at a single step process. It involves a stepwise process. That means then only we control the rate of that degradation process. Okay, after that we see the types, but before starting the types of biodegradable polymers, just I revise the overall definition and introduction. So first of all, we see the definition. Definition means biodegradable polymers. That means the polymers which are degraded, the polymers which are degraded by the biological activity. So nothing but enzymatic action of the bacteria, enzymatic action of the bacteria, and which are further capable for the degradation. And coming to the nature of the polymers, they do not undergo any environmental conditions. Nothing but reacts with the environment, oxygen and UV radiations. But some of the polymers are degraded slowly by reacts with the atmospheric oxygen and also the radiations which are coming out from a solar, that is nothing but ultraviolet radiations, but not by bacteria. So because of the especially such a type of the polymers causes the land pollution. That means disposal of that polymer is very big problem. So what are the examples for that landfills? Examples nothing but the collection of leaf and add waste. So these polymers which degrade by the enzymatic action of naturally occurring microorganisms and bacteria. So that are called as a biodegradable polymers. And initially the biodegradable polymers are used by the Romans. In the case of they are used in the catgut for the switches, which are slowly degrades as a wound heats. And now we see the basic requirement of the biodegradable polymers means that is the production of a non-toxic compound. That means they are not harmful to the human beings and they maintain the good mechanical strength up to degradation step. And the degradation steps involves in a, that means the degradation process involves in a stepwise process, and each and every step we control the rates of the degradation. Okay, and this is about the definition, introduction of a biodegradable polymers. Okay, ma, anybody define biodegradable polymers?
Ability of being chemical transformation by enzymatic action of bacteria.
Which are capable for the further
degradation.
So that is called the process of biodegradability. Okay, very good. So generally the polymers are degraded by which actions? Oxidation and UV radiation, etc. Okay, but the polymer should not undergo any biological activity. So for the purpose, it is need to create that biological activity, nothing but biodegradability. Because of that, The biodegradable polymers, especially the waste coming out from a trees like leaf and ad waste, causes so much of the land pollution. So that these polymers are degraded by the enzymatic action. So that is naturally occurring microorganisms and bacteria, and all of this comes under category of the biodegradable polymers. Okay, ma? And who was initially invented by the biodegradable polymers?
In Roman time.
In Romans, they are used in the catgut for the switches, which are slowly degraded at the wound heals. Okay, ma? So this is the initial biodegradable polymers. Okay, now tell me, what are the basic requirements for the biodegradable polymers? Your voice is very low, ma. Production of non-toxic products, and second one is they maintain the mechanical integrity until they undergo degradation step, and each and every step there is a controlled rates of a degradation. Okay, so these are the basic requirements of a biodegradable polymers. The basic requirements of a biodegradable polymers. Okay, after that we see the types of a biodegradable polymers. So because of the availability and source of biodegradable polymers, these are mainly classified into two types. One is naturally occurring biodegradable polymers, and second one is the synthetic biodegradable polymers. So these natural biodegradable polymers further classified into four types, and synthetic biodegradable polymers are further classified into two types. Okay, so this is about the classification briefly. Then we discuss about each and every one. Okay, ma? All of you visible the types of biodegradable slide, ma?
Yes, sir.
Okay. So first of all, these biodegradation and biodegradable polymers are classified mainly two types. One is naturally occurring biodegradable polymers, and second one is the synthesized biodegradable polymers. Now let us start with the natural occurring biodegradable polymers. So there is a belief that anything that comes from the nature and goes back to nature. That means each and everything present in the nature is a recycling process. So initially they start from the point of nature, and it will be go back to the nature at the end point. So then only the recycling is possible. So hence it is assumed that these natural polymers are beautiful for the environmental degradation. So the rate of degradation and the formation of metabolites depend very much on the structural complexity of material and the environmental conditions selected for the degradation. So that means the degradation of any substance, it should be depends upon its structure. That means for the chemical compound, especially the functional groups which are present in that particular substance, and we know what are the functional groups which are reacted with the another substance. For example, acids are neutralized by the bases, whereas bases are neutralized by the acids. If for example oxygens are present, they are reacted with the reductants, and neutral compounds are mixed with the neutral compound. So that means we know depends upon the functional group, that functional group how to react with the another functional group. So that those functional groups which are present in the structural complexity of the material, and also environmental conditions like temperature, pressure, all of these comes in the category of the environmental conditions, and each and everyone should be selected for the degradation process, especially in the naturally occurring biodegradable polymers. And further, these naturally occurring biodegradable polymers are classified into four types, that is polysaccharides, and examples of the polysaccharides are starch and cellulose. After that we see proteins. The examples for the proteins are the gelatin, casein, silk, and wool. And next one, polyesters, example polyhydroxyalkanates, and others are the example lignin, shellac, and natural rubber. Lignin, shellac, and natural rubber. Okay, so these are the 4 types of the naturally occurring biodegradable polymers. Okay, so that is about the natural occurring biodegradable polymers. Okay, ma. Tell me about natural occurring biodegradable polymers, ma. Emma, how many types of biodegradable polymers?
2 types.
2 types. What are they?
Naturally occurring biodegradable polymers and synthetic biodegradable polymers.
Okay, very good. So, in the case of the natural occurring biodegradable polymers, the rate of degradation and the formation of metabolites should be depends purely on the structural complexity of the material and also environmental conditions for the selected degradation. Okay, ma? So these are the conditions for the naturally occurring biodegradable polymers. Okay, and how many types of naturally occurring biodegradable polymers, ma?
4 types.
4 types. What are they?
Polysaccharides, proteins, polyesters.
And last one, others.
Others.
What are the examples for the polysaccharides?
Starch and cellulose.
Okay. And what are the examples for proteins?
Casein, silk, wool, gelatin.
Okay. And what are the examples for the polyesters?
Polyhydroxyalkanoids.
Alkanates. Okay. And what are the examples for the others?
Lignin, shellac, natural rubber.
Okay. Okay. Very good. So these are the examples for the and classification of naturally occurring biodegradable polymers. Okay. Next, we see the synthetic biodegradable polymers. Okay, ma. So that means the polymers which are produced from the chemicals and biological sources that are biodegradable. So whereas the polymers is not obtained from the nature and these are prepared from the man-made from the chemicals or biological sources that are comes under category of the synthetic biodegradable polymers. And the following are the 2 types of the synthetic biodegradable polymers. The first one is the polylactic acid. And second one is the polyvinyl acetate. Polyvinyl acetate. Okay, now we see polylactic acid. So this is simply abbreviated as PLA, polylactic acid. Okay, ma. All of you visible this slide of synthetic biodegradable polymers.
Yes, sir.
Okay. So these synthetic biodegradable polymers, the first one is the polylactic acid or polylactide. Polylactide. So abbreviated as PLA. So this is one of the biodegradable thermoplastic ester belonging to the class of polyhydroxyalkanates. Already, according to the definition, the polymers, that means which are obtained from chemicals, especially naturally occurring biodegradable polymers. So in the case of polylactic acid, the naturally occurring biodegradable polymer is the polyhydroxyalkanate. That means this polylactic acid is one of the synthetic biodegradable polymers which is derived from the naturally occurring biodegradable polymers, that is polyhydroxyalkanates. and it is derived from the renewable sources such as starch topica or sugarcane process the following structure. So these are the naturally occurring biodegradable polymers derived the polylactic acid, starch topica and starch topica or sugar cane process the following structure. So see in the structure there is a presence of a OH groups, and this is a group for alkanes, and this is a group for ketonic group, one of the carbonyl compounds, and it is a totally smaller number of moles. So where smaller represents the degree of polymerization, it represents the total number of the monomers which are participated in the reaction. So it is an example for a polylactic acid or a polylactate, abbreviated as PLA. In case of examination point of view, there is no need to write the structure, only you prepare the preparation, properties and applications. Now we see the properties of a polylactic acid. So for this polylactic acid, the glass transition temperature of the polylactic acid is nearly 60 to 65 degree centigrade, and it passes a melting point nearly 173 to 178 degree centigrade. And this polylactic acid is a chiral compound existing as a polylactic acid. That means PLA existing in polylactic acid. So chiral compound. That means because of the compound is satisfied the tetravalence of the carbon, and it is linked with the different groups. So that is called chiral compound. After that, we see the applications of a PLA. So first of all, this polylactic acid is widely used for making medical implants, especially like anchors, screws, pins, mesh, etc. Okay, so all of these comes under category of the medical implants and are made from the polylactic acid. And the second application is the especially useful for the packing material like disposable garments, food packing, etc. Okay, so this is about the applications of a polylactic acid. Okay, so this is the first synthetic biodegradable polymers, and the synthetic biodegradable polymers means the polymers which are produced from the chemicals or biological sources that are biodegradable. So this is the definition for a synthetic biodegradable polymers. And the first example is polylactic acid or polylactate, simply abbreviated as PLA. And this is the nature of this biodegradable polymer is thermoplastic polyester, and which are obtained from a polyhydroxy alkanates class, and it is derived from the renewable sources. Renewable sources means they are presented in unlimited quantity in the environment, and such as starch topica or sugarcane possess the following structure, and the resultant structure having the both OH groups and alkanates groups and ketonic groups. And the properties of the polylactic acid is, first of all, the glass transition temperature is nearly 60 to 65 degrees centigrade, and melting point of this polymer is 173 to 178 degree centigrade, and it is a chiral compound because it is existing in a PLA. PLA means the full form is polylactic acid. Polylactic acid. And the applications of polylactic acid is especially used in the medical implants like anchors, screws, pins, and mesh, etc. And also it is useful for the packing material, disposable garments, and food packing. So these are the applications and properties and preparations of polylactic acid, one of the synthetic biodegradable polymer. And next one is the next synthetic biodegradable polymer is the polyvinyl acetate. Polyvinyl acetate. So it is simply abbreviated as PVA. So polyvinyl acetate means it is a water soluble and biodegradable polymer possessing excellent mechanical properties and compatibility with the starch. So that means it is a water soluble compound and acts as a biodegradable polymers and having the good mechanical properties, structurally stable and compatibility with the starch. And the structure of this PVA is these functional groups are advanced contain methyl groups and ketonic groups and also one of the alkanate groups. And totally this monomer undergoes a biodegradable polymerization to give n moles of the PVA, where small n represents the degree of polymerization. And now we see the preparation. This PVA is another class of innovative biodegradable polymers produced from the starch, which is totally biodegradable in a wide variety of environment, as it can be hydrolyzed to the glucose by microorganisms or enzymes, and then metabolized to the carbon dioxide and water. So this biodegradable polyvinyl acetate is produced from the reactants, nothing but acetic acid and acetaldehyde, produced from the molasses by the fermentation process. So that means it is produced from the carboxylic acid mixed with the aldehydic group and like fermentation process. So fermentation process in a daily we see in our domestic purpose, that is the conversion of a milk into a curd. Conversion of a milk into a curd by the enzymatic process, nothing but biological activity. So that's why this is called as a biodegradable polymers. Now we see the properties of a polyvinyl acetate. So first of all, from the title, you understood that polyvinyl acetate means the monomer is the vinyl acetate. So it is comes under the category of the vinyl polymers, and it is a water soluble compound. That means polar compound, and possesses excellent mechanical properties and mechanically high strength, and it is compatibility with starch. That is, starch mole can be introduced into the backbone for the quick biodegradability. That means the starch will be introduced into the backbone of a structure of this polyvinyl acetate. After that, we see the applications of a polyvinyl acetate. So this polyvinyl acetate is used for the food industry. So this is about the preparation, properties and applications of a polyvinyl acetate. Just a minute. Okay, ma. Now all of you visible the slide of PVA preparation, polyvinyl acetate preparation.
Yes, sir.
Okay, ma. So first of all, this polyvinyl acetate is a water soluble and a biodegradable polymer, and possessing a excellent mechanical properties and compatibility with the starch. And from the structure, we know the functional groups which are present in the basic functional groups, that is methyl groups at one side and ketone group at the top of the ring, and at the right side there is a alternate groups. Because of these groups, we know how to degrade by this compound by another compounds. And this PVA is another class of innovative biodegradable polymers produced from the starch, and which is totally biodegradable in a wide variety of environment, as it can be hydrolyzed to glucose by the microorganisms or enzymes, and then metabolized to the carbon dioxide and water. And this biodegradable polyvinyl acetate is initially produced from the two reactants. One is carboxylic acid group, and second one is the acetaldehyde. So that is acetic acid and acetaldehyde produced from the molasses by the fermentation process. So fermentation is nothing but the conversion of a milk into a curd by the enzymatic action, nothing but bacteria. And now we see the properties of a polyvinyl acetate. So first of all, from the title I understood that the monomer is the vinyl acetate. So it is purely belongs to a class of vinyl polymers, and it is water soluble, and it possesses a excellent mechanical properties, and it is compatibility with starch, especially starch mole can be introduced into the backbone for the quick biodegradability. And the applications of a polyvinyl state it is used for the food industry such as packing material, food storage, and catering, mailing, and composable bags. Okay, so this is about the preparation of properties and applications of a polyvinyl acetate. Okay, anybody define synthetic biodegradable polymers? Ma, what is the definition for synthetic biodegradable polymers?
Which are produced from chemicals or biological processes.
Okay, ma, very good. That are biodegradable. And how many types present in synthetic biodegradable polymers?
2 types.
2 types. What are they?
Polylactic and polylactic.
Okay, ma, polylactic acid and polyvinyl acetate. Okay. So, first of all, what are the sources for the polylactic acid? The synthetic polymer slide converted. Okay, now all of you visible the synthetic biodegradable polymer slide?
Yes, sir.
Okay. Okay, tell me what are the renewable sources for the polylactic acid?
Starch, topaica, sugar cane.
Okay, starch, topaica, or sugar cane. This is the structure for polylactic acid. Okay, tell me what about the properties of polylactic acid?
It has a glass transition temperature which is 60 to 65.
Okay.
And the melting point is 173 to 178.
Okay.
And it has a chiral compound existing of polylactic acid.
Polylactic acid, abbreviated as PLLA, polylactic acid. And tell me what are the applications of polylactic acid?
It is used for packing materials, disposal garments, and food picking.
Okay.
Packing.
And what is the another application in case of medical?
Anchors, screws, and pins.
Yes. Okay, so this is about the applications of the first synthetic biodegradable polymers, polylactic acid. Okay, very good. And next, the second synthetic polymer is the polyvinyl acetate, PVA. Okay, ma. So first of all, this polyvinyl acetate is water soluble and it is a biodegradable polymer possessing excellent mechanical properties and compatibility with the starch. And the functional groups which are present in the polyvinyl acetate is methyl groups, and at the left side of the ring and at the top of the ring there is a ketonic group, and right side a group we know the alkanate groups. And tell me what are the reactants for the biodegradable polymers?
Glucose,
so first of all, this biodegradable polymers is produced from the acetic acid and acetaldehyde. Acetic acid and acetaldehyde produced from the molasses by the fermentation process. Okay, Amma? So, and this PVA is another class of innovative biodegradable polymers produced from the starch, which is totally biodegradable in a wide variety of environment, as it can be hydrolyzed to glucose by microorganisms or enzymes and are metabolized to the carbon dioxide and water vapor. Okay, Amma, now tell me, what are the properties of polyvinylistic?
It belongs to vinyl polymers. It possesses excellent mechanical properties. It's water soluble.
Okay. And it is compatible with the starch. That means the starch mole, which is introduced into the backbone of the polyvinylistic for the quick biodegradability. Okay, and what are the applications of polyvinylistic?
It is used in the food industries for packing food and caterings.
Okay, okay. Okay, this is about the overall biodegradable polymers, which includes the natural biodegradable polymers and synthetic biodegradable polymers, including their preparation, properties, and applications. Okay, all of you understood biodegradable polymers? Emma, all of you understood biodegradable polymers? Any doubt?
No, sir.
Okay, okay. So up to CIE 1 syllabus, module 1 electrochemistry and corrosion, and module 2 water technology, and module 3 engineering materials, and for the CIE syllabus, especially in the polymers, up to biodegradable polymers. Anybody having doubts? Up to 2.5 modules, module 1, module 2, and module 3. Anybody having doubts, Amma? Okay, now coming to the attendance. 701, 2, 3, 4, 5. What about 5, Amma? 5 is absent?
5 present, sir.
Present, okay. 6. And what about 7? 7 is absent?
Present, sir. He is at bottom.
Okay, 8, 9, 10. And 11? Number 11 is absent. And what about 13?
Present, sir. He is at bottom.
10, 15, 16. And what about 17? 17 is also absent. And 21?
At bottom, sir.
22, 23. And 24? (26)
At bottom.
27, 28, 29, 30, 31, 32, 33, 34. And what about 35? 36, 37. And what about 38?
At bottom, sir.
39, 40, 41, 42, 43, 44. 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 65. Yes, 7, 13, 7, 13, is 20, 26, 38, 38. Okay, ma. Finally, the option numbers are 11, 17, 24, 35, and 44. 5 numbers are absent. Okay. 11, 17, 24, 35, and 44. 5 members are absent for today's class. Okay, ma. Now all of you understood the syllabus of CIE 1 syllabus, including their topics. Module 1 electrochemistry and corrosion, and module 2 water technology, and module 3 engineering materials up to biodegradable polymers. May start from Monday onwards. The question bank of module 3.
Yes, sir.
Okay. Okay, all of you prepare for our mid examinations.
Preparing, sir.
Okay, ma. Every day I send the PPTs of each and every topic, ma, in module 3. Maybe today or tomorrow I share the material of module 3. That means up to biodegradable polymers. Okay, ma. Thank you. Thank you for your listening.